Okay, we're now going to start looking at naming and drawing amines and amides. So I'm going to introduce to you something new now that we're dealing with amines and amides. Okay, and it's because, remember, we have primary, secondary, and tertiary amines. Okay, so we can actually have multiple carbon chains attached to that amino group, to that nitrogen. Okay, and that introduces a new level of complexity when it comes to naming amines and amides. Okay. Again, we're going to follow all the same rules we've done before with all our other hydrocarbon derivatives. Okay. Now, when we have an amide, okay, amides are similar to naming carboxylic acids in that amide group, the carbon of your amide group, okay, is included in your parent chain. And that carbon that's double bonded to the oxygen, okay, is always going to be carbon 1. So when you're numbering your parent chain, it's real easy because we always start from the carbon that's part of the amide group. Now, when we're dealing with secondary or tertiary amines, it's a little bit different. Okay, and how do we pick the parent chain? So we look at this example down here. Okay, so remember an amine. Right, look, NH. An amine just means I have a carbon-nitrogen single bond. Okay, well, in this example down here, I have two different carbons. This one is attached to the nitrogen, and this one is also attached to the nitrogen. Okay. So which one's considered, part of your parent chain? Okay. So what you have to do is you have to look. So in this case, this is a secondary amine. So you have to look at all the carbon chains that are attached to that nitrogen. Okay, for your amine. And then what you have to do is you have to look at which one is the longest. Okay, and that will be your parent chain. Now, remember all of our previous rules. So let's say, okay, in this example, okay, look, I have one carbon attached to the nitrogen, and over here I have 1, 2, 3, 4. A 4-carbon chain attached to that nitrogen. So this red chain here becomes my parent. Okay. Now this is also my parent chain because I have a double bond. And remember, we have to include, when we're choosing our parent chain, we have to include all of our double or triple bonds in it. Okay. Let's do an example of a tertiary amine. Okay. Look, I've got several carbon chains here. Okay. Like, which one's the parent? Okay, so normally you would just pick the one that's the longest, okay, and that would be your parent chain. So we've got 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbons, 1, 2, 3. So one of these would be the parent chain. However, since this chain has the double bond, it is in fact the parent. Okay, so this here to here is considered the parent. Okay. There's your nitrogen. Okay, so when we number this, again, we want to assign this functional group, this carbon-nitrogen bond, okay? The lowest number possible. So we would start numbering from here. Okay, and then we would treat the other carbon chains that are attached to the nitrogen, okay, here. We would treat these as substituents, okay? One, two, three, four, 5. So that's actually a pentyl group. Okay, 1, 2, 3, 4, and this is actually a butyl group, okay? So if you have a tertiary or secondary amine, okay, you're going to want to pick the longest carbon chain that nitrogen is attached to, and that will be your parent. Okay? However, if you have a shorter chain or even a ring, okay, and it has a double bond in it, then that's going to be your parent. Okay? Now, we've got these substituents. Observe, these substituents are not directly attached to your parent chain. Okay, look, I've got a methyl group and another methyl group. So this methyl group down here is attached to our parent chain, but this methyl group is not. It's attached to the nitrogen over here. And it's fine that's attached to the nitrogen. Now I want you to observe that when we have a substituent group and it's attached to the nitrogen, all right, we denote that it's being attached to the nitrogen by using the locale. We're going to use an N. For example, here we're going to use N. Okay, and that tells me that my methyl group is attached to the nitrogen, okay, of my amine, okay, of my amino group. So N3-dimethyl tells me I've got two methyl groups. One of those is attached to the third carbon of my parent chain, and the other methyl group is attached to the nitrogen of my amino group. And when we have more than one substituent, one attached to the nitrogen and one attached directly to the parent chain, we're going to list the N first and then the numbers. Okay. Again, when we're assigning the locants here for this parent chain as well, okay, because we have a functional group, we want that functional group to have the lowest number. Okay, so we choose the red numbering because that puts this carbon nitrogen, right, that amino group, okay, on the lowest carbon possible. Okay, and remember that takes precedence over the location of a double or triple bond. Okay. We want that amino group to have the lowest possible number. Okay, so we're going to assign that number 2. Again, let's go through some examples, okay? And it gets really more complex when we're talking about amines as opposed to amides. Okay, so let's look at some examples, okay? So first things first, we have to identify what kind of molecule is this. Okay, and this is in fact, right, an amide. Okay, because here's my functional group, right there. Okay, that's your amide. So if I look at my suffix, I have my functional group, okay? I'm going to have amide as part of my suffix, okay? So remember, this carbon must be part of your parent chain, and that's going to be carbon 1. So now let's pick the longest chain attached to that, and I see a triple bond here, so when I pick my longest carbon chain, I have to include that triple bond. So this one's easy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I had another carbon chain that's equally as long, 6 carbons, but I don't pick that one because it doesn't have a triple bond. It means that we'd have a more complex substituent, right? And we don't want that. Okay, so we number 1, 2, 3, 4, 5, and 6. Okay. Again, we always start numbering. When it's an amide, we start numbering closest to the functional group, okay? And then here's my substituent on carbon 3. Okay, that's a propyl group. Okay. My root is 6, so it's going to be hex. Okay, I've got a carbon-carbon triple bond, so that means carbon 4, so it's going to be 4-ine. So you're going to put this all together, and you're going to get 3-propyl, right? We name our substituents. Hex, 4-ine amide. All one word. Okay. So the next example, observe here, look, I've got 2 functional groups. Okay. For instance, this is a carbon-nitrogen single bond. These are amines. Okay. So these are amino groups, so this is going to be an amine. You know, these are both primary amines. Okay. So when you're going to treat these as if they were like, a hydroxyl group or a carbonyl group or something like that. Okay. So we're going to choose the longest parent chain that contains both of my functional groups. So 1, 2, 3, 4, 5, 6, 7. 7 carbons. That's my longest functional group, or my longest parent chain. Okay. Over here, I have 1 carbon substituent. This is a methyl. All right. Now, let's assign locants. And again, these are considered functional groups. Okay, so remember, when we're talking about hydrocarbon derivatives, we want to assign one of our functional groups, if we have more than one, with the lowest number possible. So I'm going to start numbering from the left, because this will give this functional group the lowest number. That's 7. If I had started numbering from down here, my first functional group wouldn't appear until carbon 3. So my root in this case, I've got 7, so hept. Now since I have that's it. Okay, that's it. Alright, now your suffix, okay, you've got carbon-carbon single bond, so 8N. Now, since I have more than one functional group, I have to include the E at the end of that part of the suffix, okay? And then your functional groups, I've got 2 of them on carbons 1 and 5, so 1, 5, and multiplier di, and my suffix for this is going to be amine because those are amino groups. So I'm going to put this all together, and it's going to be 5-methyl heptane 1,5-diamine. Amine. There we go. I'm glad I know how to spell. And remember I told you always want, when we're dealing with parts of the different parts of the root and suffix, we always want to separate parts of the roots in the suffix with a vowel and a consonant. So that's why we're sort of adding that additional E there, because the next letter that comes is a consonant. So this is 5-methyl heptane 1,5-diamine. Alright, next example. Okay. Observe, in this case, look, I have a carbon-nitrogen single bond, carbon-nitrogen single bond. Okay, so this tells me this is some type of amine. And look, in this case, I have a secondary amine. Right? This nitrogen is bonded to 2 carbons. So we need to figure out which of these, well, is this chain here going to be the parent, or is this ring that nitrogen is attached to, that amino group is attached to, okay, going to be the parent? Okay, here's your amino group. Now, remember, we want to pick the largest thing that is attached to your amino group, and that will be your parent. So in this case, my chain that's attached to the nitrogen is only 2 carbons, but my ring is 6. So my ring in this case is going to be my parent, and this smaller chain is going to be treated as a substituent. Okay, so this isn't going to become the parent, it's going to be treated as a substituent. So that's an ethyl group, right? It's got 2 carbons, and so is this. This is also an ethyl group. Now we have to, now that we've identified the parent, it's going to be a ring, and my functional group and my substituents, we now need to assign locants. Remember, in a ring, okay, one of the things that are coming off the ring is going to be assigned to carbon 1, and this is a substituent, and this is a functional group. We want that functional group to have the lowest number possible, so we're going to start here at carbon 1. We can go left or we can go right in the numbering, but we want to, at this point, our first difference occurs to the right. Okay. If I had numbered it to the left, this ethyl group would have been on carbon 6. And generally speaking, right, we want the lowest numbers possible for substituents. Okay, so this is on carbon 2. This ethyl, how do we know where? Look, it's not attached to the parent chain, so I can't give it a number. How do I say where this ethyl group is? So remember, since this ethyl group is attached to the nitrogen of our amino group, we're going to use N. Okay, this is an N-ethyl group. That tells me this ethyl group is in fact attached to that nitrogen of my amine. So let's put this together. Okay, your root. Okay, my root here is a 6-carbon ring. So that means this is cyclohex. Okay, let's look at the parts of my suffix. Now, in my ring, I only have carbon-carbon single bond, so that's going to be ane. My functional group is going to be amine. Now, in this case, now I know I have multiple things on my ring, but I only have one functional group in a ring. So we always assume that that functional group is going to be on carbon 1, so I don't actually need to assign a locant here. I'm going to put this all together. So I'm going to list my substituents. So I have ethyl groups, right? And we need to say where they are. So one ethyl group is on the nitrogen, the other is on carbon number 2 of my ring. This is N2. Oh, and I forgot, since I have more than one functional group, I need a multiplier. Alright, let me just erase that. So where are those ethyl groups? On the nitrogen of my amine, carbon 2. Diethyl, because I have two ethyl groups. That's my prefix. Cyclohexanamine. This is N2-diethyl cyclohexanamine. Alright. Next example. First things first, let's identify the functional group. Okay, so I see nitrogen here, but I also see it attached to a carbon-oxygen double bond. Okay, so there's your functional group. Okay, and this is an amide. And this happens to be, in fact, a tertiary amide, because that nitrogen is bonded to 3 different things. Now, picking the parent for a secondary or tertiary amide is easy, because that carbon that's part of your functional group, okay, that's forming that double bond with the oxygen, okay, that is part of your parent chain. So we're going to start here. And we have to pick the longest chain that's attached to that carbon of my amide. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, and 5. Okay, so there's my parent chain. Okay, it's got 5 carbons in it. So my root is going to be pent. And when we number our parent chain, we're going to start numbering, in the case of amides, closest to your functional group. So 1, 2, 3, 4, and 5. Okay, everything else is going to be considered a substituent. Okay, so here I've got an ethyl group. Here, even though it's attached to the nitrogen, it's still considered a substituent. Ethyl. And that, it's a ring with 4 carbons. That's 4 carbons. Put in a ring. Cyclobutyl. Now for your suffix, I've got carbon-carbon single bonds, so this is going to be ane. And my functional group is an amide, which is always on carbon 1, so we don't need to, again, assign a locant, so this is just amide. Okay, so we're going to put this all together now. So I'm going to list my substituent groups in alphabetical order. So my cyclobutyl comes first. And we need to give it assign it a locant. So it's not attached to one of the carbons on your parent chain. It's instead attached to the nitrogen. So we're going to use N as our locant. So this is N-cyclobutyl. Now I've got 2 ethyl groups. One on the nitrogen, one on the second carbon, N2 diethyl pentanamide. So this thing is N-cyclobutyl, N2 diethyl pentanamide. That's it for naming. Again, these become more these amines are more complex, especially when you have a secondary or tertiary amine, because you have to figure out which of the carbon chains or rings that are actually attached to that nitrogen is going to be the parent. Remember, it's going to be the longest one, or it's going to be the one that has double or triple bonds in it. And whatever else isn't the parent, and if it's attached to the nitrogen, remember, we're going to consider those substituents, and the locant we're assigning to those is N, and that tells us it's on the nitrogen. So let's look at drawing. Let's do the first 2. Okay. So let's identify the different parts. Okay. So here, amide, that's my functional group. Okay. As far as suffix, what else comes before that? Diene. Diene means I have 2 carbon-carbon double bonds. Okay, and that's your suffix. Okay, the part that comes right before it is going to be your That's your root. Hepta, that means 7 carbons. Okay. And then here is your prefix, so dimethyl, so I have 2 times 1 carbons. And observe their locations, N2, which means these methyl groups, one of them is attached to the second carbon of your parent chain. The other one is actually going to be attached to the nitrogen of your amide functional group. Okay. So this is how I would draw this. So first things first, let me draw my functional group. Okay. So I will draw, here's my carbon, the oxygen double bond, and that nitrogen. Okay, that's your amide functional group. Now I'm not going to put NH2 there because right now I already know that there's something attached to it. So I'm going to leave that for now. Okay, so there's your functional group. Remember that carbon's actually part of your parent chain. Okay, so I don't even need to even actually write that nitrogen. So okay, that carbon double bonded to the oxygen and then your nitrogen. It's carbon 1. Let me draw my parent chain. 1, 2, 3, 4, 5, 6, 7. You start numbering here. 1, 2, 3, 4, 5, 6, 7. You have to start numbering in this case from the amide, okay? Now let me put in my double bonds on carbons 4 and carbon 6. Now let me attach my methyl group. So again, one methyl group is attached to carbon 2, and the other methyl group is attached to the nitrogen. Remember, nitrogen can form up to 3 bonds, so I have to include an H there as well. Okay, this is a secondary amide. Look at this example now. This one's more complex. Look at, again, start from the right. Look at your suffix amine. Well, that means this is a carbon-nitrogen bond. Okay. And then if we look what comes right before it, ane. Okay, that tells you have carbon-carbon single bonds. And then the root is going to be prop. So I've got 3 carbons. Everything else is your prefix. So I have NN13 tetraphenyl. That means I have 4 times your phenyl groups. Remember, your phenyl groups are benzene rings directly attached to your parent chain. So let's draw this out. Let me draw my parent chain first, okay? Prop. Got 3 carbons. 1, 2, 3. Let's number them. 1, 2, and 3. They're all carbon-carbon single bonds. Great. I now have a carbon-nitrogen, right? My amine, my amino group is going to go right here in second carbon. So there, N. No, I'm not going to put NH2 there because I don't know what else is attached to that nitrogen right now. Now let's look at our prefix. I've got phenyl groups, so these benzene rings. I've got 4 of them. Now NN, that tells me I've got 2 of them attached to the nitrogen. So let me draw those in. So there's my nitrogen. So I've got a phenyl group, my benzene ring. Attached to my nitrogen, I have another one attached to that nitrogen. But I have 2 more. One here at carbon 1, and another one at carbon 3. There's my 4 phenyl groups. This NN tells me that those phenyl groups are attached to that nitrogen. So then I look, okay, that nitrogen has 3 bonds. It can't form any more bonds, generally speaking. So we're done. And this is a tertiary amine because this nitrogen is bonded to 1, 2, 3 other things that aren't hydrogen.